morning, my dear students. Once again, we are continuing from what we have left on last day's class. So once again, we are continuing again Diborane. So what we are going to learn today is the structure of Diborane. So Diborane has got the molecular formula of B2H6. It has got 2 boron atoms and it has got 6 hydrogen atoms. We know the electronic configuration of boron. It is 1s2, 2s2, 2p1. Right? So in the ground state, it has got this particular structure, electron arrangement. Right? In the excited state, one of the electron will be shifted here so that it can at least form 3 bonds. Right? Therefore, it has got 3 unpaired electrons, and possibly what will be the hybridization in this? It will be sp3 hybridization that takes place. So overall, the valency electrons in boron is 1, 2, 3. That is the outermost electron. Therefore, the valency electrons in 2 boron atoms will be 2 into 3, 6 electrons. Right? So boron has got 6 electrons. If you look at the hydrogen, hydrogen is 1s1. It has got only 1 s orbital with unpaired electron. The total number of electrons in 6 hydrogen atoms will be 6 electrons. So overall, we have how many electrons? 12 electrons in diborane. So these 12 electrons in diborane will not be sufficient to form the sufficient number of covalent bonds. Therefore, it is an electron deficient molecule. So actually, in the structure of diborane, there are 2 BH2 units. BH2 units in diborane structure, right? So overall, there are 8 BH bonds, right? So out of the 8 boron hydrogen bonds, only 4 boron hydrogen bonds are found to be covalent, right? So these 4 boron hydrogen bonds will be called as 2-centered and 2 electron bonds. So in short, we will represent 2-centered, 2 electron covalent bonds that are formed, right? So apart from this, there are 2 BHB bridges connecting the 2 BH2 units. There are 2 BHB units. So in this BHB units, what are the orbitals which are overlapping? There will be one half-filled sp3 orbital of boron and one empty sp3 orbital. These are all from boron, and there will be one half-filled s orbital from hydrogen. So overall, there are how many electrons? There are 2 electrons only connecting how many centers? 3 centers. Therefore, this BHB bridge is actually called as 3-center 2-electron bond. It is called 3-center 2-electron bonds. Right? So this is the special nature of this diborane. So considering all these factors, we can go into the structure of the diborane. Right? So taking all these factors, there are 4 BH bonds which are 2-center 2-electron normal covalent bonds. But there are 2 bridges connecting 2 boron through hydrogen, and these bonds will be of the type of 3-center and 2-electron bonds. Right? Now how to put the structure, overall structure. Right? So the structure of diborane is written like this. There are 2 boron atoms, right? And there are 4 sp3 orbitals. 1 sp3 orbital, 2nd sp3 orbital, 3rd sp3 orbital, and 4th sp3 orbital. Right? So this is sp3, this is sp3, this is sp3, this is sp3. Right? And 1 hydrogen atom will have s orbital. Right? And 1 hydrogen here will be s orbital. So this will have 2 electrons. Right? And here again, this boron will also have sp orbital, 1 sp orbital overlapping here, and 1 sp here, and 1 sp3 here. So these are all sp3 orbitals of boron. So here again, 1 hydrogen s orbital will be overlapping, and 2 electrons are equally shared. And here again, 1 hydrogen, 2 electrons will be equally shared. Now this is the bridge. Here 1 s orbital of hydrogen will be present. Here 1 hydrogen will be present. So this is what we have written as BHB bridge. BHB bridge. In this there will be only 2 electrons. 2 electrons connecting how many centers? 1 boron center, 1 hydrogen center, 1 boron center. Therefore there are 3 centers. But how many electrons only used? Only 2 electrons are used. Therefore in these 2 bridge it is 3-center 2-electron bonds. Here it is 2-center 2-electron bonds. And here again it is 2-center 2-electron bonds. So this is how the structure of diborane is explained. Right? Therefore you should know that overall there are 12 electrons, but only 8 electrons are making the perfect covalent bonds. The other 4 electrons are making the BHB bridges, boron hydrogen boron bridges, and in that there will be 3 centers connected by 2 electrons. Here 2 centers connecting the 2 electrons. So this is how the structure of diborane is confirmed. Right? So this is a very peculiar structure that we come across in inorganic chemistry, and you must be very clear about this formation of diborane. So diborane will have 4 BH2 units. BH2 units here, BH2 units here, and there are BH2, BH, BH, BH. These 4 bonds are perfect covalent bonds, and these 2 are the bridges. Right? So you have to make a note of this. Then diborane is mostly used as a propellant, and it is also used as a substance for the reducing agent in most of the reactions, right? Next we will pass on to the next compound, that is boron trifluoride. So boron trifluoride has got the molecular formula BF3. Its preparation is done by three methods. One, from boron trioxide. Boron trioxide can be heated with calcium fluoride and sulfuric acid, right? Now what are the products that is formed? Boron will join with fluorine forming boron trifluoride, and calcium will join with sulfate forming calcium sulfate. Hydrogen will join with oxygen forming water molecules. So it's easy to write the products, right? Now how to balance? There is 2 boron and 2 fluorine. We have 2 boron, therefore multiply this by 2. Fluorine becomes 6, multiply this by 3. Calcium becomes 3, multiply this by 3. Sulfate becomes 3, multiply this by 3. Hydrogen becomes 6, multiply this by 3. So you get number all places, right? Should start from boron, keep balancing the next element. Your equation gets balanced. And the second preparation is also done from boron trioxide. So now boron trioxide is heated with coke in the presence of fluorine, and it forms boron trifluoride. And with that, there is liberation of carbon monoxide. Now you got to balance this. This is to be multiplied by 2, and this is to be multiplied by 3. So it is 3 into 2, 6, 2 into 3, 6. Okay. Then 3 carbon will remove the 3 oxygen, forming 3 carbon monoxide. So this way also it is being prepared. The third one is, it is prepared from benzene, diazonium, boron, tetrafluoride. So benzene is represented as pH N2 is diazonium, boron tetrafluoride is BF4. So this compound on heating is forming benzene fluoride with nitrogen gas, and boron trifluoride is formed. So instead of writing this, you can write like this also. You can put benzene ring, then nitrogen, boron trifluoride. This is how it has to be written. So this phenyl ring, benzyl ring, phenyl group is written as pH. So pH is nothing but C6H5, right? Or you can write it as C6H5 also. So this is boron trifluoride, right? So in 3 methods it's being prepared. Okay. So this boron trifluoride is an electron deficient compound, right? Therefore, its chemical properties goes like this, right? When boron trifluoride reacts with ammonia, ammonia has got a pair of electron which is readily given to boron, forming a covalent coordinate bond. This bond is called covalent coordinate bond. Nitrogen gives electron, boron takes electron. Similarly, BF3 can also react with water, and it forms same type of compound, BF3. Now oxygen giving the electron for the coordinate bond formation. So covalent coordinate bond can be formed with water molecule as well as with ammonia molecule, right? This is first reaction. Then second reaction is with boiling water, right? So boron trifluoride, when boiled with water, it forms hydrofluoroboric acid. Boric acid, along with that it forms hydrofluoric acid. right? So this how you got to balance this. We'll take 4 molecules of this. We'll get 4 molecules of this, and fluorine will get 4 into 3, 12. Therefore, hydrogen it is 12 plus 12, 24. Therefore, we will take 12 water molecules. So after this 4 boric acid, only 3 boric acids are taken, and it reacts with that 12 hydrofluoric acid, and it forms 3 H plus ions with BF4 minus 3 ions. Along with that, it forms the water molecules, right? 3 water molecules will be produced. 9 water molecules will be produced. Okay? So this sum it has to be, it needs to be balanced, right? So 3 into 3, 9 water molecules are produced. So 9 into 2, 18. Out of the 18, we have 3 into 3 here and 12 here. So 9 plus 12, 21. Here also 18 plus 3, 21. Now if you add these two equations, how to add these two equations, right? So we have 4 BF3. I will not write this because we have 4 H3BO3 in this side. We will take only one of that. About 3 cancel பண்ணிடுவோம், right? 12 HF ரெண்டு பக்கமும் இருக்குது, கேன்சல் பண்ணிடுவோம். அப்ப இங்க எத்தனை வாட்டர் மாலிக்யூல் இருக்கும்? இங்க 12 வாட்டர் மாலிக்யூல் இருக்குது. அதுல இங்க எத்தனை தான் வரும்? 3 தான் வரும். இல்லையா? Then what is left here? 3H plus 3 BF4 minus. So hydrofluoroboric acid is formed. So this is the overall reaction that takes place with water, right? So this is a very important reaction. You should write this very carefully to get this. If you connect these two, it is HBF4. It is called hydrofluoroboric acid. So this boron trifluoride is used as a catalyst in organic chemistry. It is also used as a fluorinating agent. Hydrofluoroboric acid, HBF4. Hydrofluoroboric acid is used as a catalyst also in most of the organic reactions, right? So after this you will write the test on Thursday. So Thursday test will be up to this. So you will write the test in boron, borax, then boric acid, diborane, boron trifluoride. 5 compounds you have to study and write the test on Thursday. So very few are trying the test. I think most of you are finding difficult these chemical equations. You must write and practice. You must memorize the formulas, right? So tomorrow class we will take up aluminum compounds. There are 2 aluminum compounds after that, and after that there are carbon compounds and silicon compounds. With that we will complete this lesson. Okay, take care. God bless you.